Hello, in this video I'm going to explain how to make a smart contract app on Bitcoin Cash. So since the Cash tokens upgrade, a lot more is possible with smart contracts on BCH, so there has been renewed interest in how to make smart contracts apps. 7 months ago I made a video what Cash tokens tooling was available, but since then quite a few things have changed. Now Cash tokens has already been live on the network for 3 months, so the software has matured. And so let's take a look at which tooling I would use today. I still think the video 7 months ago is very helpful, so I would recommend checking it out, but this is much more specific. So let's take a look at the tooling for the smart contract app. I'm using developers.cash and I already selected just the tools that I would use. So let's go over them quickly first. So I would use 4 libraries, all JavaScript based: Electrum Cash, CashScript, Libath, mainnet.cash. So those are the 4. Then for the network, I would use Chain Graph Indexer. So this uses a GraphQL API. And then lastly, for general tools, I would use the CashScript Playground. So this is a website. And let's actually go over them one by one and start with the CashScript Playground first. Because if you want to start development and you start with a smart contract functionality, this is where you would start. You would start with the CashScript Playground, because then you can quickly write your CashScript code, so the high-level smart contract code, which then gets compiled in the background. And there's no need to write additional code to create wallets or to create tokens, because you can all do that easily in the CashScript Playground itself. So you would just, it's a low-code environment. So you just have to, like Remix is for Ethereum. So you just have to fill in boxes and select drop-down menus. And then you can demo your smart contract transaction on testnet, for example. So this is the CashScript Playground, which uses the CashScript compiler and the CashScript SDK in the background. So let's go over those two. So CashScript actually includes 2 parts: the compiler, which compiles down the high-level language to low-level opcodes, also called raw Bitcoin Cash script. And then this creates an artifact, and then there's the JavaScript SDK, so software development toolkit, which you use to actually make transaction on the network from this artifact object. So the SDK is all hidden away in the playground, but it's very much needed if you want to make transactions yourself from any wallet. So then there's Libath. So CashScript uses Libath under the hood, and Libath is very handy for general utilities. So for example, for converting addresses from one type to another, or for getting the locking bytecode from an address. Or another example is to convert VM numbers to integers. So for these type of general utilities, Libath is a great library and pretty much the only one you can use for that. And then there's the mainnet.cash library. It also has cash token support, and it just does general wallet use cases. So whereas CashScript, the CashScript SDK, is focused on smart contract transactions, mainnet.cash does regular pay to public key hash transactions. So it's handy to have a combination, to have both currently. And then there's Electrum Cash. So this is to get the state of the blockchain from the Electrum X servers or the Fulcrum servers. You can also get subscribe to addresses, and then you will get notified anytime there's a change on the balance of a smart contract address. Then the GraphQL API. So this is very handy because this allows you to select the specific aspects of a transaction that you would want more info about. So let's actually take a look at how this works. So here's the CashScript Playground, the chain graph demo instance. So it's at try.chaingraph.cash, and I already ran the query. So as you can see, you can hover over these items to get more details, which is very handy. This example includes some extra comments, and then you can run the query and you will get data like this back. So it only returns the data that you asked for. For example, we want the transaction data for this specific transaction ID, where the hash equals this ID, and then we want the block inclusions, we want the inputs, and from the inputs we specifically want the input index and the unlocking bytecode. And as we see for this specific transaction, there was only one input with this unlocking bytecode. So this is how you would work with chain graph. And as I said, there's this demo instance available, demo.chaingraph.cache, but you can also self-host this. But there's other public instances of it available as well. An important thing to know for the libauth library is that there is two versions available. So if you go to the npm page and you click on versions, you will see there is the version 1.19, which is the default. But then for the cache tokens functionality, you would want to use the alpha version 2.0. So this is all the cache tokens functionality, which the current latest version does not. Then let's go ahead and let's delve into, if you have actually made your smart contract functionality, how would you connect this to a wallet? So there's two options for this. Either you use a built-in web wallet, so your application, your Web3 app, has some web wallet in the background that briefly holds the funds. But from a security perspective, this is not ideal. But some smart contract applications have used this, but a much more crypto-wide standard now has been the Wallet Connect. So for example, if you take a look at TapSwap, this is a demo version of TapSwap, which has Connect Wallet. And then there's two options. So Paytaka Connect, which is the thing that is currently used, but also the general Wallet Connect version 2. So the version 2 means for UTXO based blockchains, Wallet Connect version 2. And this way you can connect your smart contract apps like TapSwap, your Web3 apps, to any wallet which supports the general Wallet Connect version 2 standard. So there is actually a supporting version of the CashScript wallet, which has Wallet Connect. So as you can see, you can connect a new dApp, and this way you can actually already use CashScript, the web version, with TapSwap. So this works today, but it's still in beta version. And this work was done by Pat. So you can see the CashScript link is at CashScript Wallet Connect 2 beta.vercel.app. I'll also link all these things in the description. So this is currently the most ideal setup for smart contract apps on Bitcoin Cash, to have a Wallet Connect. And currently Paytaka uses their own version, but hopefully there will be many supporting wallets for Wallet Connect version 2 soon. So this way your wallet can sign the smart contract interaction, and you don't need to deploy your own web wallet, but users can just keep on using the wallet they are used to. So a small remark on this Wallet Connect still is this is on Bitcoin Cash research forum, so bitcoincashresearch.org. And as you can see, the Wallet Connect version 2 has been spearheaded the work by mainnet Pat. And here he does a great explanation of why it is useful going forward for Bitcoin Cash, and why it has become an industry standard in crypto, in Ethereum and the EVM. But it's still like a work in progress, so there's still changes being made to the specification. So I'd watch this closely, but this is the general setup that I would use. So I know that TapSwap also uses chain graph in the background, and also uses Wallet Connect. So I think TapSwap is a great example of how to do a smart contract app on Bitcoin Cash. And I think we can learn a lot from this. So this, to reiterate, this tooling, these four libraries with chain graph as a backend, and with the CashScript playground, is the tools that I would use to build a smart contract app on Bitcoin Cash. So I hope this helps, and see you in the next video. Bye.